Welcome back. We're going to continue on with conic sections, and we're going to focus on hyperbolas today. So a hyperbola is a shape that is formed when a plane intersects a double cone placed tip to tip. So something, I think I have a picture of it like this, in such a way that the plane cuts through both halves of the cone but does not intersect its vertex. So we can see kind of the shape that it would make on that cone if we cut that. It's defined as a set of all points in a plane such that the absolute difference of the distances from two fixed points, called the foci, is constant. Just like with ellipses, we looked at a few hyperbolas in the real world. Ellipses in the real world. Hyperbolas in the real world, the shape of a hyperbola is often used in the design of cooling towers and power plants. The hyperbolic shape helps improve airflow and cooling efficiency. There's other applications, obviously, as well. I'm not going to list them all, but here's an example of a real world type of hyperbola that is out there. Navigational systems, such as GPS signals sent from GPS satellites, can be modeled using hyperbolic equations. The positions of a user is determined based on the difference in signal travel times for multiple satellites. All right, why is my screen not moving? Okay, and so we're going to look kind of side by side at the standard form of equation of a hyperbola, along with some of its characteristics, kind of like we did with an ellipse. There's some similarities here for sure. Obviously, we can see the shape is completely different than an ellipse, but this most closely looks like an ellipse, with the main difference of we have a minus sign. With the ellipse, you have a plus sign. Both of them are equal to 1, like an ellipse. And then we'll talk about A and B, because we don't have a major and minor axis here like we did with an ellipse. So our center is still going to be H and K. And this is just where your what the curves are symmetric around. So where would you place that center? That would be like right in there somewhere. It's not exact, but anyways, there we go. We have these vertices, so it looks almost kind of like parabolas, but they're not. They have there's actually asymptotes that we can't see, but the vertex are the points where the curves are closest to each other. They represent the maximum distance of the hyperbola from the center in the direction of the opening. So I would label those vertexes like that. And then when we dealt with an ellipse, the A was always our major axis, and here the A is always our distance from the center to a vertex, to each of the vertex. So we would say something like from there to there, we would call A. We can also go to the one from the center to the vertex from the right as well. And then this would be how we would define that point. I don't really like having to think about that formula. I mean, it's not hard or anything, but we're going to graph these. I think determining what A and B is easier when we graph it, because once we know the center, we can just count over that many and determine what A is, which is essentially what H minus A means. It's just kind of confusing, I think, to some people, especially if I don't give that to you on a test. And then we have asymptotes. Remember, those are imaginary lines, but straight lines that the hyperbola approaches but never touches. They represent directions that the hyperbola extends towards. The slope of the asymptote from the center can be found by plus or minus b over a. So b is not used for anything except helping us determine what the slope is. So here's what our asymptotes would look like drawn into this particular graph. Another thing that we need to look at compared to this is that this graph happens to open left and right. Just like with an ellipse, we had a horizontal ellipse and a vertical ellipse. Well, with hyperbolas, our graph can open left and right like this one, or it can open up and down like this one. So the characteristics are pretty much the same here. I mean, they are. Our formula looks a little bit different. So one thing about our formula to note is that here our y is first. Our a is still going to be our distance between the center and the vertices, but our y is written first. And the other main difference here is the equation of the or the slope of the asymptote. So the slope of the asymptote with this one is plus or minus A over B. So I'm going to write something real quick, because I don't think you have to know the equation of the slope for the test, but you do on some of the assignments. So the way I like to remember which one's what, because one's B over A and one's A over B, is if we think slope as rise over run, like what we know. Well, rise or fall or whatever, that's the same thing as, like, that talks about our y values. Like, we go up or down, and then we go left or right, like x moves, right? And so if we look at rise over run in that capacity, we can think about, well, what is our denominator under y? And that goes first. So in this case right here, our denominator under y is a. So we can say a over b, which is what we have down here. If we go back to this, rise over run, I know it's not exactly the same, but this is just how I remember it. B over a, and that's what we get down here. So that's one way we can maybe help try to remember which one's what. And then these are our points of our vertices. Once again, notice I didn't really talk about this a whole lot, but if you do just want to use that formula, because you're gonna have to write the equation. So notice if I find out what h and k are my center, if I move up or down, h value didn't change, which is why that point is the same as our h and k, and then our moving up and down, we're just moving up and down from k, whatever our a value is. On your test, you're only going to be given the formulas along with the center. So you're not going to be given the equation for the slopes or how to find the slopes or the vertices. And which I said, I don't think you need them for the test. You may need them for a quiz and some of the problems. Okay, so we're going to determine whether the hyperbola opens left, right, up, or down, and we're going to find the center, vertices, and slopes of the line. So we're going to start with, does this graph open left, right, up, or down? Well, let's look at what is written first. Which one does not have the negative in front of it? That would be y. If y is positive, that means that we're going to be up or down, because y is first. Now, our center, when y is first, I've got to remind myself that y is y minus k. So when I write this, I don't want to do 3 comma 2. It's my h is always with x. So it's going to be 2 comma 3 for my center. And so I'm going to go ahead and plot this, and I go ahead and plot this 0.23, and then I'm going to define my a value. So my a is always it's always written with the positive one. So a squared is equal to 4. If a squared is equal to 4, that means a is equal to 2. And since I am going up and down, I'm going to go from that center, and I'm going to go 2 above and 2 below to get my other points. And now that I have those points there, I think that this is a lot easier to say, okay, what is that point? Well, I went over 2 and up 5, so that point's 2, 5, and the other one should be 2, 1. Just looking at those points to see what they are for the vertices. Now to determine my slope, so rise over run, so this one's going to be a over b, because 4 is underneath a, so it's going to be that over 16. So I'm going to find b, which is b squared is 16. That means b is 4. So then plus or minus a over b would be 2 over 4. That means from the center, I'm going to go up 2 and over 4. So I'm going to, and you can think about this too, a couple ways. I'm just going to go up 2 and to the right 4 and up 2 and to the left 4, because we're going to get 2 sets of asymptotes. So that'd be up 2 right there, and then over 4. 1, 2, 3, 4, and then I'm going to draw my line, my asymptote. And then I'm going to do the same thing, and I'm going to go up 2 and to the left. We're just trying to figure out where these things are. And now that I have these, then I can draw and fill in my the rest of my graph to look something like this. All right, now I'm giving you characteristics and I'm asking you to write the equation. So write the equation of a hyperbola that opens left and right, which tells me right off the bat that x needs to be written first because we're moving left and right. X moves left and right with the center of 0, -1. So I'm going to go ahead and define, this is the formula I'm going to use where x is first. I'm going to go ahead and define what h and k are, which is 0, -1. And then I'm going to go ahead and plot these real quick on my graph. So 0, -1. And I'm also here, since I'm given the vertices, I'm going to go ahead and plot those, and then I'm going to look at the distance between them. And from this point, I want to go left and right, not up and down, because the equation is telling me the hyperbola opens left and right. So I don't want to go 3 up or 1 down. I want to go, I want to plot this point. Actually, I don't need to even think about that. If I plot this point, -3, -1, that's going to be right here. And 3, +1 is going to be right here. And I can see after I plot these points, these 3 points, that it's going to open left and right. So the distance, what is that distance between that? I went 1, 2, and 3. So what does that give me? That gives me my A value. And to find B, see if I do that next. Okay, to find B, I'm told that the slope is 1. So, and my equation for this slope, my formula for this slope is the rise. I'm going to think about that as rise over run. So what variable is in the denominator under y? That would be b over a. So I'm going to think about this as b over a. And from that center, if I go up 1 over 1 on both directions, I get something like this. But I'm going to plug this, if the slope is equal to plus or minus b over 1, and I'm told the slope is 1, well, we know what a is, and we know what the slope is, so let's substitute some of these values in. So I can substitute 1 for the slope, and I'll substitute 3 for a, because I know what those are, and if I do that, I can solve for b. And I get b is equal to 3. Now that I know what a, b, and h and k are, I can plug all of those into my formula and get this equation of the hyperbola. All right, we're going to determine some of the same characteristics. This time we are not given our equation in standard form. So I'm going to start by doing what we've already seen. I'm going to group my x and y's together and move my constant. So the first thing is getting our x's and moving the constant to the other side. I have a coefficient in front of my x squared and my y squared. So I'm going to factor out a from each group. So factored out at the 9 from the x squared and the -4 from the y squared. And then looking at that first group with the x's, if I do -2 divided by 2, so I'm going to add b over 2 squared to each group. So I do -2 divided by 2 squared, which is 1. And notice on the right side, I went ahead and put that 9 and that -4 there, so it would remind me that I'm not really adding 1, I'm adding 1 times 9 because I factored out the 9. So on the other side, if I'm adding 9 to one side, I need to add 9 to the other side. On the second group with the y's, I'm going to do 4 divided by 2, which is 2, and I'm going to square 2, which is 4. So I'm going to add 4, but I'm multiplying that by the -4 that I factored out right here. And now I can kind of clean this up a little bit, factor, rewrite, and simplify. So if I factor the first group, that gives me x minus 1 times x minus 1. The second group, x plus 2 times x plus 2. I want to clean up the right side by multiplying 9 times 1, -4 times 4. And then I'll add 43 and 9 and -16 together. And then I'll also rewrite those as binomial squareds to get the following. This equation is not equal to 1, so we're going to divide everything by 36 to make it so. And then I'm just going to reduce my fractions to get something like this. Now I can look at this and answer the following questions. We can see clearly that x is written first, so this is going to be opening up left and right because x is first and positive. So let's go ahead and plot, my h and k is 1, 2. Let's go ahead and plot that point. And then a squared is going to be equal to 4. So that means a is equal to 2. So I'm going to go over 2 to the left and over 2 to the right from the center to get the following 2 points. And then I'm just going to write those down. That's -1, 2, and then +3, 2. Remember, slope is rise over run. So looking at the denominator of the y with the denominator of the x. Well, actually, I need to find b first. Let's find that. So b squared is 9, so therefore b is equal to 3. So then I have plus or minus 3 over 2. So I'm going to go up 3 and over 2 on both sides from the center, and I get something that looks like this. So we've already talked about this on day 1. Why are they called conics? And you will have a test question that has something to do with this. It will give you a scenario where it says, like, a circle is formed by doing what? Or not a parabola. An ellipse is formed by doing what? A hyperbola is formed by doing what? And so these are the types of things that you need to, the verbiage that I'm going to use in the test. Circle is formed by cutting a cone horizontally parallel to the base. You don't need to know the parabola. Ellipse is formed by taking a plane and intersecting sides anywhere except parallel to the base and not all the way to the bottom of the cone. So look at the difference. I know you don't need to know parabola, but look at the difference between the parabola and the ellipse. The parabola intersects the plane anywhere except parallel to the base, but it also goes down and touches the base, like it's angled at where part of it actually touches the base. Ellipse does not. And then a hyperbola is perpendicular to the base. So what you need to know on your test for conic sections, you don't actually have to graph these by hand like we've been doing, but I think it's easier to determine A and B sometimes when we do graph those and get a visual. So you will have 2 problems where I give you 4 equations and a graph, and you have to tell me which equation matches the graph provided. So you're going to look for things like the center, and then also look for things like what would A and B be, and that's pretty much kind of how you're going to approach those. You'll be given a problem that asks about conic sections as a result of cutting a cone certain way, so like what I just told you guys in the last slide. And then you need to be able to tell me where the center and radius is of a circle from looking at the equation of a circle, which should be hopefully fairly easy in a gimme type of problem. That's just h and k, and remembering that you need to take the square root of the square root of what's written for the r squared to find out what the radius is. And then you need to be able to write a conic section equation in standard form by completing the square like we have seen for either a circle, ellipse, or hyperbola. And then one way you can kind of tell the difference between these, like a quick little cheat sheet to have on, because on this particular one that I'm going to ask you about, which to rewrite the equation, I'm then going to ask you what conic section that is, and you're going to need to be able to tell me if that equation is the equation of a circle, an ellipse, or hyperbola. And a circle, both terms are positive, and that is equal to something other than 1. So that's equal to radius squared. An ellipse, both terms are positive, and your equation is equal to 1. And a hyperbola, one term's positive, one term's negative, and it's also equal to 1. So your job is to finish worksheet 13.3, and then this is what we should be at in terms of hyperbola. So your delta mass should be all up to this point before you come to class next time. Good luck. Make sure you ask questions, and we'll see you next time.